guys, you have finished unit 2. You have finished unit 2. You took the last quiz. There are no more lessons for unit 2. Forces, you guys have finished it. You took the last quiz, which was unit 2, lesson 3. Over the weekend, you took the last quiz. So what we're going to do today is we're going to go over the quiz, and then I'm going to tell you what's next, what's going to happen next, okay? But first, let's start with the quiz, okay? Let me share the quiz for you guys. And you guys are going to help Mr. Connor take the quiz. Mr. Connor doesn't know the answers. You guys have to help him get through it, okay? You guys are the experts now. You guys are the experts. You have to help Mr. Connor. So let's look at each question and we'll just go through them one at a time, okay? So this was the questions you had for your quiz this weekend, okay? Now let's have someone read the first question. Kim, can you read number 1 for everyone? Kim, can you read number 1 for everyone?
Which of these describes how an electromagnet works?
Okay, and is it A, works on static electricity, works when electricity is on, works when magnets repel each other, or works on 2 magnets with opposite poles? How does the electromagnet work? A, B, C, or D? Circle the answer you think it is. Circle the answer you think it is. You guys can draw. You guys can draw. In 3, 2, 1, go. Which one do you think it is? We are not scribbling though. We do not want to scribble though. Okay. There we go. So good job, guys. So it looks like you guys are split between 2 answers. We have A and B. A and B. Okay. So you guys are choosing between these 2. Which is what I expected. So works on static electricity, works when electricity is on, works when magnets repel each other, works on 2 magnets with 2 opposite poles. And the question was, which of these describes how an electromagnet works? Which one of these did you choose, Ray? Ray, which one did you choose?
I choose B.
Okay. Zook, which one did you choose? Zook, which one did you choose? Zook, are you able to unmute? Okay, Zook, I think struggling a little bit to unmute. Sino, which one did you choose? Sino, which one did you choose?
I choose B.
B, very good. And finally, Puppy, which one did you choose? Puppy, which one did you choose? Are you able to unmute, Puppy? No? Okay, okay, Puppy's eating, that's okay. So guys, the correct answer was B. B. If you chose B, you got it correct. B is correct. It uses when its electricity is on, Remember, static electricity is a little bit different. Static electricity is when 2 surfaces you rub them together to produce static electricity. Okay. Okay. An electromagnet works through when the electricity is on. So answer B. Let's go to number two. Number two, Jack Fu. Jack Fu, can you read number two for everyone?
What happens if we put the same two magnets together?
Okay, Jack Fu, what do you think happens when you put two magnets with the same poles together? What's gonna happen? What do you think is gonna happen, Jack? What'd you answer, Jack? What was your answer? Jack Fu?
Yeah.
What would you answer on the quiz? Nothing happens. The magnets repel each other. The magnets attract each other, where the two magnets become one magnet.
The magnets repel each other.
Okay, so we have A answer B, the magnets repel each other. Lisa, what did you choose? Lisa, what did you choose for this one? What happens when the poles are the same?
The magnets repel each other.
Okay, so Lisa also believes they repel each other. And then Banana, what did you choose? Banana, what did you choose?
The magnets attract each other.
They attract each other, okay? We'll get one more. Moon, what did you choose? Moon, what did you choose?
The magnets repel each other.
Yeah, they repel each other. This one is correct. Answer B is correct. Answer B is correct. And Moon, why is C not correct? When do magnets attract each other? When the poles are what? When the poles are opposite. Opposite. Very good. And these ones are the same. These ones are the same, not opposite. So B is correct. If you answered B on the quiz, you got it correct. Okay. Let's have someone else read. Let's have, well, this is a lot of reading. This is a lot of reading. Let's see who can do it. Let's have Scart. Let's see if Scart can do it. Let's read number 3.
Mary made a metal game board and put it on her wall. She made wooden game pieces to put on the game board. She wants two game pieces to stay on the board without falling off. The game piece should be easy to remove and so she can play the game again. How should she attach the game piece to the board?
Thank you, Scart. Thank you, Scart. That was a long one. That was a long one. So Mary has a metal game board. Mary has, so guys, when you're reading this, you guys need to make a metal game board. They're made out of wooden game pieces. They're made out of wooden game pieces. And she wants these pieces to stay on the board. Stay on the board without falling off. The pieces should also be able to be removed. They should also be able to be removed so she can play the game again. Okay, how should she attach? How should she attach the game pieces to the board? Should she use buttons, glue, magnets, or nails? Okay, type me in chat. Let's see who can get it in chat first. Type me in chat. Okay, Taylor got the correct answer. Lucky got it. Good job, Sarah. Okay, you guys all got this one. Taylor, let's call on Taylor. She was the first one. She won the race. Taylor was the first one. Let me find Taylor, ask him you. What did you write, Taylor? What did you write?
I choose magnet because that magnet can put out and stick on.
Yeah, what happens if you use glue? What would happen if you use glue to try to attach?
And if you don't play for a long time, you can't put it out.
Yeah, if you didn't play for a long time, all your pieces would be permanently stuck to the board. They'd all be stuck to the board. No one would be able to move. Imagine a chess game, but no one can move the pieces. Yeah, C is correct, guys. C is correct. Magnets. You don't want to use glue. You don't want to use buttons. You don't want to use nails. Especially nails. That sounds like it could hurt. Thank you, Taylor. Okay. Number 4, which magnets will attract? Which numbers will attract each other? A, B, C, or D? Let's have Emma. What do you think, Emma? Which ones will attract?
B.
And why did you choose B, Emma?
Because the poles are opposite.
Yeah, the poles are opposite, and you can see the magnetic fields. Very good. The poles are opposite. You can see the magnetic fields. They're trying to attract each other. They are attracted to each other. So B is correct. The poles are opposite, and you guys can tell by the magnetic field. You guys can tell by the magnetic field. So B is correct. C, for C, if you guys look, the magnetic fields are repelling. You guys can see that the magnetic fields are repelling each other. There's no magnetic field between them. Okay. So B is correct. B is correct. Good job. Okay, number 5. Uh-oh. Let's see what's going to happen. Sarah, can you read it for class? Sarah, could you read it for class?
Hector the come with a wall close. Next, he held the comb near, but not touching some bit of paper on a plate. Which of these is most likely to happen?
Yep. Which can you say the word most? The word most.
A mouse.
Very good. So what's he doing right now? So can you explain to me, Sarah, after reading that, Hector's rubbing a comb on wool cloth. What do you think they're talking about? What type of force do you think they're talking about before we even read the answers? When you rub, this is kind of like your experiment at home. So what are they looking at? What force are they looking at, Sarah?
Static electricity.
Yeah, static electricity. So we already know we're looking at static electricity. Good job, Sarah. Let's see what answers sound like static electricity, okay? So let's read the answers. A, the paper bits will move away from the comb. The paper bits will not be attracted to the comb. A spark will jump between the paper bits and the comb. The paper bits will be attracted to the comb and will stick to it. What happens with static electricity? Milk. What is going to happen, Milk? A, B, C, or D?
The paper bits will be attracted to the comb and will stick to it.
Exactly, guys. If you guys remember your static electricity, it can cause things to stick to the balloon or the comb or whatever you use to produce static electricity. Some of the paper bits will be attracted to the comb and will stick to it. It almost kind of works like a magnet. It's almost like a magnet because there's so many negative charges. Okay. Okay, so now we have our writing questions. So you had to write these down, okay? You guys on your quizzes, you guys have sometimes struggled to write. Sometimes you guys don't use complete sentences, okay? And the last time Mr. Connor graded all of your writings, and I had to give less points to people that did not write full answers. Some of you guys only wrote 1 word, 2 words, and these are for ones that wanted entire sentences. So make sure you try to answer the questions the best of your ability. Make sure to write as much as you can, explaining your answer. Okay, write your answer on the lines. Now, number 6 was a smaller answer, so it's okay. But identify the pair of magnets that repel each other. For this one, it's not asking you guys to explain or anything. So you just have to identify the pair of magnets that repel each other. So you need to look over here and tell me which ones would repel each other. Which ones would repel each other? Misha, which one did you choose that would repel each other?
I choose the picture B.
Picture B. Why did you choose picture B, Misha?
Because picture B, the poles, 2 poles of the picture B is the same poles.
Exactly, Misha. So what we would write, identify the magnets that repel each other. You could write picture, maybe picture B, or you could write like example B. Maybe you wrote magnets B. Something like this to let us know that you wanted to answer. It is just for B. It's B, okay? Either one of these, any of these are good. Picture B, example B, magnets B, whatever you want. And then Misha already explained why, but why would you choose, explain why the magnets you chose would repel each other. Moon, why would they repel each other?
Because they are same up. They are the same poles.
They are the same poles. They are the same poles. So you guys could write the poles are the same. Now, guys, when you're writing, you want to try to use as much vocab as you can. So we've already used the word poles, which is great. Let me highlight all of our vocab. So you use the word poles. This is great. So why do they repel each other? Because they're the same. But what is surrounding them? What causes them to repel each other? What's that invisible thing that repels them? So we should try to use another word. Sina, what's the invisible thing that is around a magnet?
Magnetic field.
Yes, so you guys could also write the magnetic fields. The magnetic fields will cause the magnets to repel each other. So these are some of the things you needed to write. The poles are the same. The magnetic fields will cause the magnets to repel each other. Okay, these are some sentences you could write. What else did anyone else write? Did anyone else add anything else? Raise your hand if you wrote anything else. Did anyone write anything else that they want to share? Zook, did you write anything else that you want to share? Zook? Did you write anything else? What did you write for this? Do you remember?
I write because the poles are the same.
Yeah.
I just write that.
Okay, so because the poles are the same. Yeah. And guys, if you're gonna write the poles are the same, let's say you guys just write the poles are the same. You should at least say, after you're saying that, you should say, so they will repel each other. This should be your first sentence. So they will repel each other. The magnetic fields will cause the magnets to push on each other. This is another sentence you guys could have wrote, okay? There's tons of different examples that you could have wrote, but guys, you needed to explain to me why they're gonna repel, and you had to recognize it's because the poles are the same, and the magnetic fields. If you mentioned both of these, you'll probably get 100%. Make sure you explain. There's a reason why it says the word explain, okay? Try to explain to your fullest ability. Okay, guys, that is it for your quiz. Good job. Mr. Connor still needs to grade all the writing on the quiz, but you guys, we'll make sure to send you guys your scores for your quiz, okay? But this was the last quiz. This was the last quiz. So let me go to my PowerPoint. So what is next? What are we gonna do next? We have finished all the quizzes in our forces unit. You guys finished the lesson 1 quiz. What are forces? You finished the lesson 2 quiz, types of forces. And now you have finished the lesson 3 quiz, forces from a distance. What are some forces from a distance? So lesson 1, lesson 2, and lesson 3, you have finished. What do you guys think is next? Does anyone know what's next? Anyone have a guess? What do we do after we finish all of the quizzes? What is gonna happen next? Banana, do you know what we do next? What do we have to do next, Banana? Take the what? It's the bigger quiz. We have to take a what?
Take.
What's the long quiz? What's a very hard quiz? It's bigger than a quiz. It's bigger than a quiz. Oh, they're saying it in the chat. Asa says test. Taylor says test. Emma says test. We're gonna be taking a test, guys. Okay, so we're gonna get ready for your test. We have a test coming up. This will be your first test of the year. Your tests are a lot more serious than your quizzes. The quizzes are serious, but the tests will be covering everything. The tests will cover everything we have learned this year, all of it. You have to remember all of it, okay? Pasa, please stop requesting the screen, okay? What you need to know. You're gonna need to know different types of forces. You're gonna have to know a contact force, a non-contact force. Remember, contact forces are touching. Non-contact forces are not touching. Balanced forces versus unbalanced forces. A strong force versus a weak force. And you're also gonna have to understand what a net force is. A net force is, okay? So we're gonna spend the next 2 days, at least, probably Tuesday and Wednesday. We're probably gonna spend Tuesday and Wednesday reviewing for your test. Reviewing for your test. You guys will then take your test. You guys will then take your test, okay? So the next few days is to get ready for your test. So make sure you guys come to class ready. We'll be playing games, we'll be taking quizzes, and we're gonna make sure you guys are ready for your test, okay? Now, the first thing I'd like to do before we get ready for your test is we're gonna take the pre-test together. We're all going to take the pre-test together so we can see what we need to focus on for our test, okay? The test is gonna be long. The test is gonna be long. I'll figure out how many questions it is, and it's pretty hard. So we're gonna have to make sure we do a lot of review for the test, okay? And I wanna make sure you guys are ready for your test. So let me present you the pre-test. So this is our pre-test. Let me switch the pages first. This is still your quiz. So we're gonna take your pre-test together. And then tomorrow we are gonna start the review. Tomorrow we'll start the review. I was gonna start today, but it's Monday, so there's really no reason to start the review. We'll just take the pre-test together, okay? So let's read each question and circle the correct answer. So this is your pre-test. This stuff will cover everything of the entire unit, okay? This will cover everything in the entire unit. So good. I have Kim, can you read number 1?
The diagram shows a crane picking a piece of iron. Which problem is being solved by the use of a magnet in this picture.
Good job, Kim. And can you say the word solved for me? The word solved.
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 Very good. Yep, solved. Solved. Okay, so what is being solved in the picture? What is being solved in the picture? What is this a picture of? What is this a picture of? Does anyone know? Ray, what is this a picture of? What does the picture look like?
The picture looks like that the crane is picking up pieces of iron.
Yeah, it's picking up pieces of iron. How is it picking up pieces of iron? How is it picking up pieces of iron? Taylor, how's it doing it? Taylor, how's it picking up the pieces of iron?
Because the metal disc have a magnet, so it can pick up iron.
Yeah, it's picking up iron by using this metal disc. It's probably actually using what type of magnet do you think, Taylor?
Not sure.
Do you think it's just a regular magnet or an electromagnet?
I think it is a electromagnet.
I think so too. Why is it important that it's an electromagnet? So you can do
So
what with it?
Turn off and turn on.
Yeah, because what would happen if it couldn't turn off? What would happen to all these iron pieces if it couldn't turn off? What would happen to all these iron pieces if it didn't turn off? Oh, Taylor muted. Sina, what would happen to these pieces if it could never turn off?
I think like if they cannot turn off, they cannot put those metal into the batteries.
Yeah, they would never drop. They would stay on the magnet forever. Imagine you had a magnet and then iron got on it and then you had no way to turn it off. The magnet would just hold on to the iron for the rest of your life, And you're not strong enough to pull that off. You're not strong enough to pull that off because that's a very strong magnet. So yeah, that would be silly. That'd be very silly. Okay, so let's read the answers and figure out which one we think it is now that we've looked at our picture. How to build tall houses, how to make iron magnetic, how to move heavy objects of iron, how to hold the crane and iron pieces together. So what is being solved? How to build tall houses, how to make iron magnetic, how to move heavy pieces of iron, how to hold a crane and iron pieces together. What is being solved? Let me see if I haven't called on yet. I think we need to call on. I haven't had Ray answer a question. So Ray, what do you think the answer is?
I think the answer is C. How to move heavy pieces of iron.
Yeah, I agree. Ray got it correct his first try. It's to try to move heavy pieces of iron. Very good. It's to move heavy pieces of iron, okay? Because they're really heavy. They're hard to move. Okay. This one you guys should all remember. This one, guys, you should all remember. Which picture shows a push? Which one of these shows a push? Everyone should remember this. Puppy, are you able to unmute now, Puppy? Which one shows a push? You guys can type me in chat. Type me in chat if you want.
The picture A.
Picture A, yeah, you remember, this is a push. What are all the, so what's option C and D? What are they doing in C and D, Puppy?
They are pulling.
They are pulling. This one is pulling. Okay, and this was a push. And then B, he's just holding a football. Okay, those are, yeah. Sam got it. Sarah, good job. Taylor, good job. You guys all got it. Good job. Thank you for typing me in the chat, guys. Okay, so let's do number three. The picture shows an objects that are charged and the objects that are not charged. So there's objects that are charged and objects that are not charged. Which picture shows objects with the same charge? Oh, sorry guys, I don't know what that noise is. But we have A, B, C, and D. A, B, C, and D. Which picture shows an object with the same charge? The same charge. Let's have pasta. Which one of these shows us with the same charge?
Her name is Pie. B.
B has the same charge. Why is B have the same charge?
No, it'll be C. Because they
C.
are moving. Because they are moving away from each other. Short I.
Yeah, they're moving away from each other
Yeah,
because this charge is what? The charge is the what? The charge is the same. The charge is the same. Sorry guys, I don't know what's happening. I'm gonna close Discord real quick. I don't know what's happening on Discord. Okay, anyways, so C is correct. C is correct. They're pushed away from each other. What is D? Who can tell me what's happening in option D? What's happening in option D? What are these pulls? These pulls are what? Emma, what are the pulls in option B? D, I mean, in option D.
Electric charge.
Yeah, but what are they charged? Are they going to be opposite charged or the same charge?
Opposite.
They're opposites because they're doing what? What are they doing?
They are pulling each other.
Yeah, they're attracted to each other. They're attracted to each other. Exactly. Exactly, Emma. Okay, what is static electricity? What is static electricity? Is it A, B, C, or D? A flow of electrons, an electric discharge, a repelling between electrons, and a buildup of an electric charge. Guys, give me 1 second. I need to do something. I don't know what's happening with Discord right now. It's usually never this loud. I don't think Discord's open. Guys, give me 1 second. I'm sorry, guys. I don't know what those noises are. I'm gonna just end it. Okay, maybe that's gonna help. We'll see. Okay. So what is static electricity? Is it the flow of electrons, an electric discharge, a repelling between electrons, or a buildup of electric charge on something? What is static electricity? This is a hard one. This is a hard one. Who thinks they know? I'm going to answer in 2 answers in chat first. We'll go. Whoever answers in chat first will go. Oh, Lucky got it right away. Lucky got it right away. Keep on answering in chat though. Oh, Lisa got it too. Good job, Lisa. Good job, Puppy. Good job, Sarah. Sarah, you need to change your answer though. Okay, Lucky. Where is Lucky, Funny, Bunny, Sunny, Sarah, Violet? What did you answer?
My answer is D.
The answer is D. The answer is D. And how do we build up an electrical charge on something? How can we do this at home? Build up an electrical charge. Oh, you already muted. Guys, don't mute right away, silly. Let's have Lucky. Lucky, what do you do to build up an electric charge? How can you do this at home?
I rub it with the towels.
Yeah, you can rub an object. You can rub an object on a piece of cloth or a towel. You could also, like, let's say, Bunny, let's say you wear socks, right? If you wear socks, you can rub them on carpet. You could rub them on carpet and then shock someone. If you guys have never done that, that's a lot of fun. You can rub your socks on carpet and then go over to someone and touch them, and you might shock them. You might shock them. Or if you rub your socks really hard on carpet and you touch a piece of metal If you go over to a piece of metal and touch it or get very close to it, you might see a static, you might see like electricity jump from your finger to the piece of metal. Okay, we only have three more. I'm only going to go over number 7 today. I guess we'll only go number 7 because we don't have that much time left. So let's just do 3 more. So let's have Sino. Can you read number 5?
Two balloons from the desk so that they are together but not touching. Jay grabs one balloon with a wool cloth. He does nothing to the other balloon. What happens if he let go of the balloon?
Okay, so Jake hangs the 2 balls. So he's or the 2 balloons. He's hanging. He's rubbed one with a wool cloth. Okay, so let's see what you guys think is going to happen. Alex, I haven't heard from Alex
I
yet
think
today.
they touch one another.
You think they touch one another? Okay, Alex, what do you think?
I think static electricity. I think the toy car had to slow down with a friction. So rolling it from cement and onto grass was make.
Yeah, but no, we're not talking about that, Alex. We're talking about balloons. We've charged one balloon. What do you think is going to happen to the balloons when we let go of them? Are they going to push one another apart? Are they going to touch one another and pop? Are they going to touch one another and stick together? They're going to stick together. Yeah, because you've done what? One of them is charged, right? One of them is charged, and they're going to attract. Exactly, Alex. And Alex, could you actually read number 6? Could you read number 6 for everyone?
Which change in force would make a car slow down?
Okay, what would make it a toy car slow down? Kicking it, giving a push, pulling it with a string, or rolling it from cement onto grass?
Rolling it from cement onto grass, because cement, if the cement is a liquid, there's least friction. If the cement is a solid, there will more friction.
Okay. So yeah, so the cement has less friction than the grass, is what you're saying? So it might slow down? Yeah, I don't think the cement is liquid. So I think they're taking it from cement onto grass so it would slow down. D is correct. Okay, guys, that is it for today. Let me show you guys your homework, and then you guys will have review with Miss Kim Ong. Okay, so let me show you your homework. Okay, so your homework is to choose any force that we have learned about so far this year. You can use a friction, gravity, static electricity, magnetism, etc. Any force you want. It can be one of these I give an example of, or something else. Choose any force you want, and pretend you have to teach your sibling or another classmate about that force. Imagine you're teaching your younger brother or your younger sister, or maybe a classmate that is getting confused. Maybe one of your classmates is confused. They're like, hey, Taylor, I don't understand magnetism. Can you explain magnetism to me? Okay. And then 3, write down how you would explain that force to your sibling or classmate. So write down how you would explain magnetism, or explain electricity, or explain static electricity, or yeah, so you'd write down how would you explain the force. Explain the force, how it works, okay? Explain how it works. You could talk about the objects repelling, attracting. You're gonna have to write down a few sentences to explain, okay? Make sure you explain. And then I also want you guys to include one example of an experiment that you could do with them to observe that force. What experiment would you want to do with them to help them observe that force so they can see that force? So maybe you choose static electricity. What's an experiment you could do with static electricity? Bunny, what's an experiment? Or Sam, I haven't called on Sam yet. Sam, what's an example of a experiment we could do with static electricity?
The one with kind of spark.
Yeah. So we could take a spork. What could we do with it?
Like draw one. We rub with something and keep it close to the metal, and then there would be a spark from it, like from your hand to
Okay.
the.
I see. So you're going to build up a static charge and then get it close to metal to see if static electricity jumps from the piece of plastic to the piece of metal. That's a really cool experiment. That's a really cool experiment, Sam. Good job. That'd be a lot of fun. Once again, you can also do that with your finger. You can also do that with your finger. You can touch like a piece of metal with your finger after building up a static charge, and sometimes do that. But yeah, that is your homework. You have to explain, choose a force, explain the force to your sibling or classmate, writing it down. Make sure you write down what you would say, and then choose one example of an experiment you would do. One example of an experiment you could do with them to show them. Remember, you're trying to help teach them. So you guys are going to be the teachers for homework. You guys are going to be the teachers for homework. So I'll see you guys tomorrow. We're going to start the review tomorrow. We're going to start a fun review tomorrow. Bye-bye, guys. Have a good day.